Hi and welcome to my 8th video in this series about genes, and today we're looking at Huntington's disease. Huntington's is the disease that affects thousands of people in the UK, and it's caused by a dominant allele, which unfortunately means you only need one of those alleles for the disease to be expressed. So technically there's no such thing as a carrier with Huntington's disease. You're either a sufferer or you're healthy. Some of the symptoms of Huntington's disease, because it's a disease which affects the brain, it's related to things like loss of muscle control, forgetfulness, loss of understanding. Something else with Huntington's disease, it's usually later onset, so you don't start to notice the symptoms of the disease till you reach roughly around 30 years old. I mean, in some cases soon, in some cases later, but generally speaking, Huntington's disease tends to be late onset. So we have here a family tree diagram, and the family tree diagram shows whether the individuals have the disease or do not have the disease. So if we look at the top line first, the parents Carl and Sarah. Now Carl is a man with Huntington's and Sarah is a woman without. I'm just going to give you a second to think about what you think the genotype of Carl and Sarah might be. So with Sarah it should be quite straightforward, because Sarah is a non-sufferer and because the disease is caused by a dominant allele, then the only possible permutation that she could be is small h, small h. Carl is a bit trickier to establish. Now Carl could be either heterozygous or homozygous. He must obviously have the Huntington's disorder, so he must have at least one allele. But deciding whether he's big H or big H small h, then you need to look at their offspring. If you look at the three offspring with Liam, Kate and Susan, then it's Kate is the one that really gives away what Carl's genotype is. Because they could give birth to an offspring that doesn't have the disease, it therefore means that Carl must at least have one healthy allele. Therefore, Carl must be big H small h, so that's his genotype. And so we can probably establish then what all of the other offspring, we can actually look at what their genotypes are and their partner's genotypes are as well. So we can see that Lisa, because she's healthy, that means she must have both healthy alleles. Liam, because he's a sufferer, but because Sarah is his mother, he must have at least one healthy allele. Kate, healthy. Susan must be a sufferer but also must be heterozygous, and Sean, obviously because he's healthy, has both recessive alleles. So obviously on the bottom row you have John, Alex, Joe and Paul, who are all healthy, who do not have the disease, and you have Emma, who's one sufferer. And again, her genotype, because her parents are Susan and Sean, she must have received the recessive small h from Sean, and because she actually has the disease, she must have received the dominant Huntington's allele from Susan. Okay, so in summary, Huntington's, what does it affect? It affects the brain, so it affects things like memory, and it can affect things like movement as well. Why are there no such things as carrier with Huntington's? Because it's caused by a dominant allele, it means that you either have it or you do not. You don't carry the allele for it, because you'll either have the disease or you won't. So if a heterozygous father with Huntington's breeds with a healthy mother, what's the probability that the child is a sufferer? Draw a diagram to help. So a heterozygous father. So heterozygous meaning he's got two different alleles in his genotype, so big H, small h. So in half his sperm he has the big H, which is causing Huntington's, and he has the small h allele, which means it's healthy. And the mother has this genotype, so small h, so in all of her eggs she carries small h. So you can see here that the offspring, these two here will be completely healthy, and these two will be sufferers, and therefore it's 2 from 4, therefore it's 50%.